predict is going to happen? Which one do you think will fall more slowly and hit the ground last, the hammer or the feather? Yes.
I predict the feather would fall last because it's really light.
Kids come into even the most basic of science classes with a repertoire of ideas developed from their everyday experience. It's a kind of reality that kids have constructed for themselves, but it may not correspond to the actual reality with which the universe presents us. And aligning those two realities can be one of the most challenging and rewarding tasks of a science teacher. How do you take a child's understanding of nature and bring that understanding in line with what nature is actually doing in a way that is satisfying for the kids themselves? The key idea in the GEMS program, the way that science is approached, is to give kids the tools to discover the ideas and facts for themselves, to put together a kind of mental picture of how the world works by gathering data, by comparing what we know to different possible ideas or theories, coming to a conclusion, and talking about it.
I don't think the planets would be in basically a line going that way.
Yeah, that's what I was going to say too.
NASA has been involved in education and public outreach since its inception almost 50 years ago. And they support activities such as development of curriculum materials for K-12, for students and for educators, starting from the very young, because it's important to inspire the children from the very beginning.
What I'm going to do is I'm going to back up, and I want you to be looking at your planet X and planet Venus at the same time. And when I back up and they look like they're about the same size, I want you to raise your hand.
And that's why NASA has invested into this wonderful resource, the formalized ideas into a curriculum material called the GEMS Space Science Sequence, so that educators and students can take all of that knowledge and that inspiration and put it into a practical application that will help them through all walks of life.
I want you to predict what do you suppose is going to happen with Mercury and Venus and Earth as Mars does Mars orbit. In your head, make your prediction. 1, 2, 3.
The students in this classroom are forming a human model of the solar system. They're grappling with complex concepts about the behavior of objects in space and learning through doing. This human orrery activity is just one of the activities in the solar system unit of the GEMS Space Science Sequence for middle school students.
Well, we've had an experience with Lawrence Hall of Science even going back before the sequence in working with them to develop curriculum. And the kind of curriculum that they do is very appealing because it fits in well with the way scientists actually do science.
Mercury, what'd you do?
I had to go around more.
What happened for you, Venus?
I'm still going in the same circle.
It is hands-on, it's minds-on, it gets students actually thinking about the activities that they're doing, trying to teach the content to them at a deeper level rather than just having them memorize facts to regurgitate on a test. These were the kind of people who were doing curriculum that really fit well with NASA's goals.
GEMS curriculum sequences consist of units, each varying in length, with each unit focused on carefully selected foundational concepts. Curriculum sequences provide in-depth instruction around a core of essential concepts that address educational standards with the goal of building students' conceptual knowledge and inquiry abilities.
Building a chance for students to learn in depth involves creating a sequence, a collection of activities that build on each other, that are coherent, that enable them to become experts. So when we set about to develop the sequences, we had scientists around the table helping us figure out what is really the most essential content in the discipline.
So the first unit on scale, in that one we go, well, what's in space? What have you seen in space? The sun and the moon, you've seen those, right? And the earth we're standing on, you've seen that. So these are 3 things we've seen. Let's focus on those ones. So that's something we decided in this group. Let's focus on 3 things they can actually see.
We like to think of the GEMS curriculum sequences as curricula that's cognition-based, taking into account what cognitive scientists have come up with over the last 10 years about how kids learn. They might be reading and they might be doing, but the goal is their understanding over time.
We've added 3 more of these to the concept wall today, and I'd like to ask someone to read this first one that goes to here. Who would like to read that one?
Air resistance acts against the movement of objects through air.
Instruction in the GEMS curriculum sequences emphasizes key concepts. These concepts are derived from the National Science Education Standards, AAAS benchmarks for science literacy, and multiple state standards. This ensures that teachers can directly align their presentation of sequences to the standards they are expected to teach, and provides a scaffold for further instruction, helping students articulate specific learnings and place what they learn in context. Sequences are flexible enough to be taught all in a single year or over several years across the designated range of grades. This allows schools to teach topics at grade levels specified by local standards and to apportion the time devoted to a particular topic to best suit their needs.
One of the principal strategies for years for GEMS has been that all their curriculum that they produce is rigorously tested in real classrooms. And we certainly employed that here as well. We had initial pilot testing in local classrooms, which became a national field test, which went out to teachers in classrooms around the country.
The units are designed to build on one another, but are also written so individual units can be taught standalone.
Here's something that I have that helps me to find out what you're thinking. It's called a questionnaire.
Each sequence has an integrated assessment system, including pre- and post-unit questionnaires and embedded assessments that allow the teacher to gauge student progress throughout the unit. In addition, critical junctures appear at points in the units where students must grasp a key concept before they can successfully move on. Providing more experience activities are suggested as needed to support and facilitate student learning.
When a teacher gets a curriculum sequence, what she's going to get is a teacher's guide that explains what she needs to know to present the unit. So that includes not only step-by-step suggestion for how to go through a particular session, but it includes information related to management, related to science content.
Do you remember yesterday we couldn't agree what the last planet was going to be from the cards? And it was number 8, which was planet Mercury.
We have some just-in-time information that enables her to read a bit of brief background at an adult level that helps prepare her to present that information. We include pedagogical content, knowledge, accommodations that you might make for struggling readers, for English language learners, optional activities that you can do if you have more time and want to engage more in a hands-on way.
The teacher's guide is carefully organized for easy use. The left-hand side of the guide provides step-by-step presentation instructions. The right-hand side contains a wide range of scientific information, pedagogical guidance, assessment suggestions, and ideas to help students who are having difficulty. It also includes descriptions of instructional routines that repeat throughout the sequence. The students in this classroom participate in a routine called an evidence circle.
Look at the 2 first ones. The last one and the first one. They're too low to be together. But they're not too big. Yeah, but this one is...
Evidence circles provide students with the opportunity to collect and discuss evidence to support explanations.
Look at Jupiter.
Like scientists, they try to convince their peers that there is evidence for their conclusions. They learn that science is evidence-based and gain valuable experience in the language of science, scientific argumentation, and making explanations from evidence. A complete materials kit supports the activities in the curriculum sequences.
If an astronaut dropped a hammer and a feather on the moon, what do you think would happen?
The space science sequences also include a CD-ROM that features videos, images, and simulations, a tool that field testers found to be a powerful aid to learning.
What did happen to the feather and the hammer when he dropped them?
When they dropped them, both of them went down at the same time.
Another highlight of the curriculum sequences is the use of short readings. These readings place what students are learning in a real-life context, describing people who have played key roles in advancing science or current discoveries and issues.
When we begin to think now anew about how to teach science, we are looking at giving kids a sense of becoming players in their own understanding. And that's what this curriculum does well. Getting kids to act like scientists is one of the most important things we can do for them, and not just for their science learning. Teaching science through this kind of inquiry-based approach and giving kids lots of chances to inquire, to learn, to argue, to examine facts is a skill which can stand them in good stead for the rest of their lives. So if we're going to equip kids for the 21st century and maybe their kids for the 22nd century, we have to allow them to be consumers not just of what we know, but how we know it.